Awesome. First and foremost, I really appreciate everybody hopping on. I know your time is valuable, but in my world, PMing and benchmarking those PMs is even more valuable. So I certainly appreciate, again, your time for hopping on to learn a little bit more about what you can do in your shop, some quick fixes, some easy things to implement, and then I'll go into a little bit about descaling and things of that nature. So first and foremost, if there's one thing I want you to take away from this, is that you start documenting things in your tool room. It, you know, as we go through, I guess, life and career changes, oftentimes I'm in a shop where Joe Schmo behind the bench has been working on all your molds for the last 20, 30 years. And Joe retains all that knowledge up here. Well, when he retires, how are you going to know what's going on within that tool? So I urge you to start documenting. And I'm not talking just like a little notebook. You can find software that can integrate into your systems. That way, as you're PMing at the bench, you can green light, yellow light, red light tag some molds. And then should you have any turnover, somebody that walks in, new tool lands on their bench, they should be able to see the history of that mold. Steve and Glenn out at the MoldTrax facility in Ashland, Ohio, they have a great software program that is actually on a little tool cart. Carolyn, if you can pull up the drop box and show what I'm talking about, just so you guys have a visual representation. Dock station. So you click on that. This is something that I see more and more in shops. I know some of you might have just rolled your eyes and said, oh, great, we've got to document and benchmark things. I understand a lot of molds are landing on your bench, and, you know, job numero uno is PM everything within that mold, get it back into production or back up on the shelf and on to the next one. This little dock station that they have integrates a software. It's on a dolly with its own computer. It rolls right up next to the shop. So instead of somebody scribbling on a notepad, it's right there off to the side. So you can hand back to me if you want. That's a great tool to have. Again, please document things. Moving on from there, an effective PM and how to benchmark specifically your cooling passages. And this goes, you know, obviously I represent EcoPro, which is a cart and chemical combination. This goes for any descaling system that you decide to bring into your shop. The two most important tools that I can think of and that I carry on me are a flow meter, which you guys will get to see in action in a little bit, as well as an endoscopic camera. You can get these nice little cameras. I buy them in bulk off of Amazon, $100, $125. They're really nice. They're waterproof. The boroscope, I think, is 0.5 millimeters. So you can get into some of those that have, you know, the 200 series fittings, things of that nature. You can get into those smaller ones. They did upgrade, and they now have a new camera that has a single lens on the top, as well as a lens on the side. So should you run into a 90 degree and you've scoped it down, you can shoot down and see the lines. This is good because, and again, whether or not you use my descaling system or somebody else's, if you're documenting visuals and tying it into those programs or the software that you decide to use, especially as you're starting up your PM program, let's say 5820 is the mold that lands on your bench, you scope it, you start to see some really nasty crud, whether it's calcium, silica, manganese. I see a lot of iron deposition. It gives you a visual representation. So if it takes you, let's say, 4 hours to clean everything back down to bare alloy, well, the next tool that comes in, again, when you're starting to implement your PM program on flushing out your cooling channels, you can say, hey, look, this looks in better condition than mold 5820, and I spent 4 hours there. Let's spend 2 hours here and see how it works. That's step one. Step two is to get a flow meter. I carry two on my persons. One is from Berger and Brown. This is a digital flow meter on this side. And then I have a pressure regulator, simply because when I'm demoing out in the field, I have the cavitation of the air diaphragm pump, kind of causes it to jump 1 or 2 pounds. So this allows me to dial it in and give somewhat of an accurate reading. If you have a dedicated station at your shop where you can have a constant flow, getting a flow meter allows you to benchmark your GPMs. I usually recommend before and after. So again, going back to mold 5820, I don't know why that number stuck in my head, but let's say you hook it up prior to descaling with whatever equipment that you choose to do so, and you're getting a reading of 4 GPMs. Hook up your descaling unit, go back to your flow meter, and if you're getting 5 GPMs and you use that endoscopic camera in conjunction, and you say, hey, this tool almost looks brand new, you know that your top benchmark is now 5 GPMs for that tool. It runs production, lands back on your bench. You hook up the flow meter, and if it reads 4.9, you say, okay, well, plus 0.1 GPM is an acceptable tolerance. I don't even have to descale. If it drops down to 3.5, you're like, okay, we can get better flow. I've seen it, we've benchmarked it, and we've documented it. We've got 5 GPMs, and we need, and we're all set to go. Another really good one that I like to use, they're a little bit higher of a price point, but this is a Keyence flow meter. It is a clamp-on style. So you can actually, you can run that digital flow meter inline, or what I like about these is it gives me the ability to go throughout the facility, right? Not just at the bench itself, but if I've got a pipe, and now the newer models even read hydraulic oil. If you're concerned about flow going to your machines, you can start taking readings throughout your facility. You'll see in a little bit, these are actually hardwired in, but I've got a little portable battery pack, again, for doing demonstrations. These weren't that much. I want to say $100. That way, if you were to go that route and want to benchmark GPMs throughout your facility, you're not tied down to any electrical. So those are the 2 most important tools and the least expensive options that you can get to start benchmarking and documenting the mold cooling channels in your molds. And that also goes for heat exchangers, TCUs, feed sections. If you're in extrusion, you know, your chill rolls. If you do sheet, your chill rails. What else? Water jackets, all sorts of things. It's one thing to clean. It's another thing to know visually and have hard data that it is clean. So with that, I think I'm going to talk a little bit about our EcoPro unit. We designed this. I started off with the EcoPro 360 chemical doing surface application treatment and using the rust inhibitor that's in there, cleaning platens, backs of molds, things of that nature. And we received a call from a gentleman that said he loved our chemical, but it was burning up his pump every 3 months. We thought that was a little bit ridiculous, so we set out to build our own. And after doing some research, we found that using an air diaphragm pump over an electric pump gave us 2 main advantages. One being every shop has accessible air throughout the facility. And 2, the safety component of it being that this pump, which I'll demonstrate here in a little bit, will actually pause operation when it reaches 10 pounds less than your current air supply. So if you're pushing 100 pounds and it senses a blockage and there's 90 pounds on that line, it just pauses. Whereas a traditional electric pump is just going to keep hammering liquid until a line ruptures downstream. And, you know, there's all sorts of caustic chemicals out there, and I'm certain you guys don't want to be around it, let alone have a line rupture and it just starts spewing acid everywhere. So that's why we went with an air diaphragm pump. That gentleman that brought it to our attention, he took the very first cart off the line in February of 2019. Actually, I take that back. He took the 3rd cart off the line. This is my demo unit number 2. I have a demo unit 1 that's behind Carolyn. He has been using the same chemical, the same 15 gallons of chemical that he purchased in February of 2019 since that time frame. The consumable item on this system is our 5-micron filter. Most commonly asked question I get is, how long is the filter life expectancy? Well, it depends on how bad your tools are. I've got some users that go through 1 filter every 2 molds, and I've got other gentlemen like this, the guy that took the first one, that goes through 2 filters on an annual basis. And again, you're really not going to know without that visual representation what kind of contaminants that you're pulling out. Earlier, I mentioned that the pump pauses operation when a pressure blockage scenario rears its ugly head, excuse me. The same can be true of the filter on the back, which I'll go ahead and turn this around so you can see it. So if I go to a facility and we start hooking up to a mold, which this happens quite often, and I'm showing 5 GPMs of flow and we're cleaning out and everything's good and we're sitting there talking shop, and then about an hour later, you kind of see those GPMs drop to 4, 4.2, and they'll say, what's going on? Like, your chemical's not working. It's not cleaning out those contaminants. The first thing I check is the filter. There's a bypass on it right here. That filter can act as a pressure point on the system. So I'll bypass the filter. If it kicks back on, then you know the filter is spent. I do have recommendations from other people that are like, well, why don't you, put in a filter gauge? Well, that adds to my cost. I am trying to compete as far as performance goes with some of the higher end pieces of equipment that are out there, which I'm sure you've seen. But I want to keep my price point entry-level friendly. I do have customers that make modifications to the cart. I'll bring out a new one soon. I'm sure you can see that this unit is rather dirty, at least on the front and the top side. Again, this is one of the original carts, so you can kind of see that the chemical, after being left on for a little bit, kind of discolors this silver powder coating. She doesn't look pretty, but she's still kicking. So I'm not going to be demoing with one of my new carts. So the 3 changes that we made on the new carts, which images are available online, I'll also pull one out of the box when I get to the point about what you can expect when you receive a cart, are that we powder coated it black, a gloss black, that the Eco Pro won't go after that color. There is also a Velcro strap on the front. I had some users that were wheeling this from facility to facility that were complaining that the drum might jockey off if you hit some bumps and bruises. So now there's a Velcro strap. And then the last change was that instead of vinyl lettering, now we have laser engraved plaques. Just gives it a little bit more cleaner of a look. So they're all purely cosmetic upgrades. What else? Filter life expectancy, we went over that. The pump life expectancy is 3 million strokes. Each cavitation of the pump counts as a stroke. And I did the math a while ago, and it was, if I was pushing 100 pounds of air into this and had this thing wide open, again, I'll hook it up so you can hear it. I just don't want the noise to interfere with my mic. That roughly translates to, you would be needing to run this unit for 8 hours a day, 5 days a week for 11 months straight before you hit that 3 million stroke capacity and needed a pump rebuild. I do have some customers that have hit that mark in a year. They're running 24/7 and they're going through their catalog. But most users can expect about 3 to 4 years of lifetime out of that pump before needing a rebuild or a replacement. So what else? It operates very simple. Again, shop air. There are 2 hookups in the back. This one's labeled blowout air. This one is labeled pump air. There is a 3-way valve underneath the top shelf of this cart with 2 one-way check valves. So this valve only moves 90 degrees and it corresponds to each of the air hookups that you're to. So if I'm set up to pump air and my valve is set to blowout, it's just not going to work. That's pretty much all there is to operation. So with that, I'll hook it up, and I'm also going to demonstrate that blockage scenario that I mentioned as one of the safety features of the pump itself. I guess before I do that, when your cart comes, the lances on the front side of the drum will be tucked in the back. Again, I'll show you. Those just go in the front. There is what we call a pressure release valve, which has a small little lance right here. And again, I'll demonstrate this here shortly, and a relief valve. So if you run into a blockage scenario, and I would say an average blockage clears up in about 2 hours. I've had some clear up in 2 minutes. shout out to Carolyn on the YouTube. There is actually a video cleaning up a conformal sprue bushing in about 30 seconds that I was not anticipating. The purpose of that video was to demonstrate a pressure blocked scenario, and it cleared up on camera, which was pretty cool for me at least. So let's say you're hooked up to a mold, you run into a blockage scenario, it doesn't clear after 2 hours. That's a way to relieve all that pressure. I tell users, swap the in and out and hit it from the backside. So that's that. This is labeled outlet. This is going to be the supply to your mold. So we'll actually, this is just a little makeshift 3-way shutoff valve so I can demonstrate an actual blockage. I'm going to hook that up. I'm going to hook up my flow meter. Sorry, I don't have a mold here. We work out of our warehouse. I don't necessarily have standard molds in your shop. Hooking up my battery pack. So the first thing that you want to do, speaking to the chemical, the chemical is 85% water, 7% phosphoric acid, and the other 8% the inventor's not giving up as a trade secret. I have every reason to believe that they are surfactants and inhibitors. But point of me telling you that is water will dilute the chemical. So you want to make sure that you blow all the water out of whatever it is that you're flushing. Now, I'm not saying that, 2 or 3 ounces over time is going to dilute 5 to 10 gallons of material, whatever you decide to bring in. But over time, obviously, if you're flushing and you're adding 2 ounces of water each time, that will affect the chemicals reactivity. So we're hooked up. We've blown out. You hook up your shop air. I'm going to hook up to my pump air side. Now, earlier, I also mentioned running full bore. There are flow control valves on the back of this cart, which help you control the velocity of the chemical that's going into the cart. That hose fitting leaks. The only scenario where you'd need to be opening this wide open, and kind of I alluded earlier and spoke about shortening the lifespan of the pump, is if you're jumping 8-10 circuits at a time and you need that sheer velocity to get through everything in your mold. As long as you've got good flow coming back out, there's no need to crank it up. So right now I'm hooked up, pump air. I slowly turn the unit on. Just kidding. And there you have it. I've already made that mistake, which I do this for a living and it's very common. My check valve was placed on the blowout air side. So now that I'm hooked over to pump, turn that on. This is going to my mold. This would be coming from my mold, returning to the drum. I currently have the filter and bypass, but it would fill up the canister and return before the drum. It's going to be kind of hard to show that far away, but okay. On these flow meters, you can set your parameters to GPMs. And what will happen is, let's go back to the mold 5820. If it was set to benchmark at 5 GPMs and I set this at 5 GPMs, this light will not turn green until it hits the threshold that I set it for. So that's kind of nice. It also gives you a nice representation when you're across the shop and you don't know if it's done flushing, because this unit is safe to walk away from. So if you're just looking across the shop and you say, oh, now it's green, we've hit what we, again, documented before, we're good. So set that back down. Just kidding. Pressure block scenario. Shut off this valve and you'll hear the pump start to slow back down. And there you have it. So if you run into those blockages, lines aren't going to swell and spew acid everywhere. Now, I do want, the magic's in the chemical. I do want it eating away at the contamination. So once flow is achieved and I still have the air on, you open that back up, pump's going to keep working. And then it's really going to clean out the contamination. So that's how that operates. Like I said, it's not extremely complicated by any means. The magic, again, is in the chemical. Let's show some pictures. Sorry, did you want to say something? Yeah, I'll just show the pictures briefly, and then we'll get to a few of the questions, because I think that's pretty close. I do want to talk about O-rings and manifolds. So earlier I mentioned really bad. Go to heavy FE before. This is a scenario, again, using the endoscopic camera, and I'm going to shut this off just in case it's messing with the mic. When I see something like this, obviously there's some fresh calcium buildup on the most ID part of this buildup. What I don't know is underneath that is if it's iron or not. And I don't care who you are, you're not gonna, the only way to get rid of iron is to gun drill it out. And I always preface that. I'll say, hey, look, I can clean up this first side. This is also what helps with the flow meter. So if you click the left arrow, this is what happens after. You can kind of see the shiny specks. I know that's iron. It's removed quite a bit. This is after about an hour. So I haven't quite removed all of the corrosion that's still on the walls. I know if they run it for about another 2 hours, that will be eliminated. But again, those shiny spots, if you want to go back to the main menu, those are iron deposits, and those aren't going to come out. Another decent one, if you scroll up, D in before, D after. Similar scenario, and then go to the after. And if you guys want, I should mention that Carolyn did record this, so eventually it'll be up on our YouTube channel. But if you ever want to see pictures or anything, I've got, I don't know, 1,000 photos. See in before, see after is good. There's the after. So you can kind of start seeing the chemical work its way. You can start seeing the ID of the bare alloy. So we know it's working, it's pulling that contamination out. But again, this is a great representation of, well, how long do I flush? Well, how bad is it? If you know these pictures, say, okay, that one took an hour, we'll run it for 3. So Carolyn, if you go back and scroll down to tech before 1 and 2. This is a mold that we went in, we cleaned out our initial cleaning, tool ran production, lands back on the bench. Again, we had the previous data of the first pictures that weren't that beautiful. These are the secondary pictures. That's another shot of it. Secondary PM. Now, granted, this mold is only 4 years young. So here you can see that on that secondary PM, we really cleaned everything out, and you can show them the tech after 1 as well. We got everything back to bare alloy. It looked brand new. It's great. And that company has now decided that every 3 PMs they hook up the mold. So if you can go back one more, I want to show another one, the tech before 90, tech after 90. This is that same tool. And back one, similar results. But the reason I showed you those D and C in and outs is because 90% of the tools that I'm called in to flush don't look like this. This is just a company that saw its effects on the tools in poor condition. This is what you can expect if you start this from the get-go. If you want to go back and scroll up a little bit, moderate before, moderate after. Go forward. Down, moderate before, moderate after. You're on heavy. Down. Down, you're going up. So now you need to go forward. Now that you've seen the after, the forward is, there you go. This is probably a little bit more indicative of people that have maybe used the descaling equipment in the past and regularly keep up with it, but are looking for something as a safe alternative. So now hit the previous button to show after. This is after 1 hour. Cool. Go back to the main. I just want to make sure there aren't any pictures that I missed. We're good there. So if you want to get it back to me. So those are, you know, there's quite a wide range of conditions in your passages, which again is why I recommend carrying one of these endoscopic cameras on your tool or on your bench. Another common question that I get is, well, I want to flush through my manifolds. Okay, well, your manifolds are the first spot that water hits. And what can happen, now these are off of mod blocks, not tubular, they're anodized aluminum. The EcoPro 360 will not etch any metals, whether they are ferrous or non. They will, if left exposed, tint your non-ferrous. Typically I run into beryllium, copper, and aluminum, but that's, again, if you don't wipe it dry and it's left to sit on there, you'd have to go back and do some polishing work. But getting back to the manifolds, again, they won't etch any metals, but a common thing to be aware of is, let's say some of these ports weren't plugged all the way and flush with the ID. What can happen is these contaminants, and I don't know how well this is going to focus, so I apologize. Contaminants can start, let that try to focus, attacking the threads on the inside and eating away your alloys, right? Thereby leaving voids. And what happens is those same contaminants, they fill that void. Kind of acts like a little Band-Aid. So you don't know there's leaks in there. When you hook up a descaling unit that is meant to attack these contaminants, it eliminates them, finds all these voids, and then you'll have a leak site. So that's always my word of caution when you decide to flush through the manifold. I do have a lot of users that say, you know what, we're just going to buy a brand new manifold and dedicate it to hooking this up, that maybe they've got 90% of their tools is universal to that manifold. That's a great idea to do, but just word to the wise. Moving on from there, you might have noticed that this O-ring was broken. Again, the contaminants underneath of it ate away at the alloy, attacked that O-ring. So what I decided to do, one of our main distributors is PCS. I decided to order every O-ring that you can from their website, pens, bushings, you name it, and I just stuck them all in jars. Now these, I stopped checking at the 18-month mark, but these are dated 3/17/2020. I had full expectations that on O-rings, whether it's silicone, Viton, Buna, EPDM, PTFE, I had full expectations that over a certain amount of time, I had 6 months in my head, those would swell up and dry rot. But I wanted to be certain. So we'll grab some of these. So I fully suspended it. They've not been moved since. What I found is that none of them, I don't know if that looks good or not. They still have their flexibility. They did not swell up and dry rot, and I've so many jars. Now, I also preface that by saying I understand there are different manufacturers of different O-rings. Again, the ones that I order are direct from PCS. So I always tell guys, if you're uncertain and there is an O-ring that you use in 90% of your tools, just take a little bit of the chemical, get an aerosol cap, and fully submerge it. Check on it after a week, check on it after 2 weeks, 3 weeks, 5 weeks, what have you, just to see if there's any swelling or dry rotting. But I am 98% confident that whatever O-ring that you're using will not swell up and dry rot or degrade. Speaking of which, I know it's probably a 50-50 base camp, but I fall in the base camp that if you're PMing a tool, the cheapest thing that you can do to help the longevity of that tool is replace O-rings. I've been in shops where guys grease them up and they go right back on. Again, it depends on your background and what you're used to, what you were taught, but I'm of the base camp. It's a cheap thing to replace easily, so I always recommend doing it. I mentioned earlier non-ferrous alloys, so I've got some copper. This was a copper elbow. Again, fully submerged for going on 2.5 years now. I can just wipe off some of that. I guess it's attached itself to it, sorry. I'm not good at looking down and trying to look at this camera. The alloy is still intact, not etched or anything. Set this down. This is a brass spacing rod. If I can get it out. It's kind of brightened it up a little bit. Still fully intact. Granted, I clipped that. That's why it's shorter. Another component that you might wind up running, I mentioned earlier, if you're going to jump some circuits, are your hoses. There's your rubber hose. It's gotten a little firm, but it's still got its flexibility, but no degradation on the inside. Things to be aware of when you're flushing. If you can go back to the drop box one last time and pull up the discoloration picture. Again, it's a water-based chemical. So I run into its discoloration. I run into facilities that are running glycol. Glycol is oil-based, water and oil, which you guys may be laughing, but I've had to explain that. So this is after a demo. A facility was running, I want to say 50% glycol. So when I brought the chemical back, and it winds up turning at this milky green, which you can see in the top right black bucket, then I know that I've run into glycol. Well, you might be saying, I don't run glycol in my facility, so I don't have to worry about this. Well, what happens if you bring in a tool from a sister facility and you're unaware, or a customer sends you a mold and you don't know what they did? If you see the chemical turn this color, you know that it's glycol. And what I did in this scenario, I let all the sludge fall to the bottom in that orange bucket. I siphoned off all the green, and I was left with nice green translucent chemical, which is what your EcoPro should always look like. So just be aware, that's usually one of the things that I see, not terribly often, but it is something that I like to speak to when discussing the chemical. I feel like I'm missing something, but how are we on time? We're about halfway through, so I think I've answered a majority of what I typically say in a shop. There are a little bit more detailed videos on YouTube on specific applications, like how do I hook up to my heat exchanger? You know, because you can plumb in line and not have your maintenance team pull one off. It loves copper. Usually heat exchangers clean up in less than an hour. Chemicals reusable as long as you keep it filtered out. I will speak to its disposal, as that's a commonly asked question. My official answer is check with your local laws and regulations as far as disposals. I do have some facilities that do medical molding, and maybe they have a little bit more strict standards. I ship them a sample. Hey, you're welcome to test as you need. But what I found, and we do sell quite a bit in California, is that most users can get away with a 4 to 5 to 1 dilution with water, and they can put it down their drain. Now, obviously I want you to be able to recapture and reuse, but you're going to have scenarios where it spills. And I actually get some laughs sometimes when I go do a demo, because maybe there was a fitting that leaked, or, you know, the most common area is if somebody cross threads this and it drips down. But I've had some leaks off of tools, and I'll just ask for shop rags and I just mop it up and I just start cleaning cleaning rust off of tools. So there's that. Carolyn said some questions have come in, so I will leave my short presentation at that. I will also state, because Carolyn yelled at me if I don't, if you're not already subscribed to YouTube, please go to our channel, subscribe. We're constantly putting out content. If you want to see more content or something specific, please let us know, across all product lines. And questions?
I will send the link to our YouTube page in the chat here in just a moment. I will read some questions that have come through the chat. I know Brian just touched on disposal of any chemicals that you should check rules and regulations of your area, but this question did come in. It says, we use phosphoric acid for our descaler media. For disposal, I hear we just need to add baking soda to get pH up to 7 and can pour down a drain. Do you know what the industry standard is to dispose of this once the pH is higher than recommended use?
Great question. I will be very blunt. I do not know the industry standard. I am not in the waste disposal business. I know enough about my chemicals as it pertains to interacting with any alloys or seals or anything within your facility. So I would say you'd want to contact your local waste disposal company, especially because ordinances are different from spot to spot, right? Earlier I mentioned California. I don't want to pick on them, but they have a little bit more strict standards as far as disposal goes. So Baking soda I think is more of a home remedy that maybe guys just were taught growing up, which I can also say a lot of guys were taught, to shoot air through a mold. And if you feel it on the other side, green tagging it out, it goes. Well, now we're learning a little bit more about conformal cooling and Reynolds numbers, which I did not mention earlier. Carolyn, if you could pull those tabs up. The more you learn about things, the less likely you are to, I guess, believe the hype on home remedies. Berger and Brown has a Smart Flow edition, or a subsidiary, if you will. These are free tools to use. This specific one is scientific cooling. So if you can slowly scroll down, you can select your polymer, you enter your molding variables. You don't have to click everything as long as they can see that. Your desired Reynolds numbers, your water temp, your delta T, your cooling circuit, that's blocked. I assume it says diameter, but click over to the next tab. These are free calculators. This is finding your Reynolds number. So if you're in the base camp that, hey, we're not getting mold cooling, let's just crank it down a couple degrees, or let's increase the flow. Odds are that's not what you need to do. Achieving turbulent flow and capturing all the heat transfer energy, if you want to scroll down just a little bit, Carolyn, to where you can see the turbulent flow and laminar flow, keep going, right there, to where you can get the maximum amount of heat transfer from that alloy out of that cooling passage. Finding your Reynolds number is a vital thing. So if you scroll back up just a little bit, so right here, this is your steel temp on the side. So if your steel temp's 115 degrees and you've got half a GPM, your Reynolds number is below 4,000. Whereas ideally, you'd probably want to be in the 6,000 range, maybe 5,000. But you can also see by just increasing the flow, going along that same line at a 105, if you find your Reynolds number to be at 4,000, your gains by increasing 0.75 GPMs aren't that great at all. You could need to increase the temperature of your water, which if you scroll up just a little bit, Carolyn, you can kind of see your water temperatures. If you're adding glycol, the diameter of your tool, then you calculate the results. And then on that previous scientific cooling calculator, you can plug in, hey, I want to hit that 4,000 Reynolds number. Then you can start adjusting your processing parameters. Those are great, again, free tools that I reference quite a bit. Smart Flow, again, Berger and Brown. They also, not only do they supply fantastic flow meters, they also build custom manifolds. Check out their website. They're not only are they great people, the product is equally speaks for itself. So
I'll also make sure to send those links in the chat as well, so you guys can use those. I will go on to the next question. Is this pump system compatible with hydrochloric acid?
I will say no. I have had one cart returned to me. And this is just me being full transparent. He said my chemical didn't work. This gentleman, I think, was just kind of in the trenches, so to speak. And he went and purchased hydrochloric acid, and it damaged some of the fittings. And I probably still have that cart somewhere around here. Came back, everything was orange. I'm like, you didn't use my chemical. I've only done testing on my chemical with this. You are free to try other chemicals on your own. It'll void the warranty. But I know specifically hydrochloric acid will not stand up to it. That was a fun day from that gentleman. Good question, though.
Okay, next question is, some conformal cooling channels can be smaller than conventional drilled lines, but equivalent in flow to standard small bubblers. At what pressure/flow rate will the machine shut off due to its sensing a blockage that might only be a small volume water line?
Sure, that's a fantastic question. And I've done some of those tools. I think the most I've done were 96 bubblers when I jumped a whole mold. And you do see that restriction in flow. What helps is having this flow regulator here, so you can kind of adjust it according to your needs. I don't recommend, if you're going through a lot of baffles and bubblers and things that are, you're going to a smaller die in your lines. If you can isolate 1 or 2 circuits versus obviously the more you add, the more restrictions that there are. If you can isolate 1 or 2 circuits, especially on your initial cleanings, you can adjust the flow. And as long as you've got good flow coming back out, you'll be just fine. I don't want you to have to crank this up full bore and expect the best results. I'd imagine if you did that, it would sense that blockage and that buildup, and you might see a shut off, or won't shut off. Sorry, it would pause. So, I want to make sure I answered that question in full. That one do the sensing of blocks. It's 10 pounds less than your current air supply. Good question. Yep, next question.
Okay, so the next question, I do think you touched on this a little bit, but someone asked if you can use different metal types, brass, O-rings, and then also pH or safety of exposure to the chemical.
Sure. I did touch on the metals and O-rings. Again, non-ferrous alloys, if you leave it on there, will stain those. So I always usually recommend, or even if you've got beryllium copper inserts, let's say you're flushing closed mold and you don't know that there's a pinhole leak, and the descaling is the last part of that PM process before you throw it up on the shelf. Sorry, I can't see. There we go. And let's say there's a pinhole leak and you pull it down and you open it up and you see a little bit of staining on those non-ferrous alloys. So I just tell people, get in the habit, when you're done descaling, back flush it with water. That kind of gets you in the habit. I can't go through every mold with everybody that says, hey, that might stain if there's a pinhole leak, back flush with water. So as a blanket general guideline, when I help customers get set up, just get in the habit of back flushing with water for 10 minutes, which if you got a flow meter set up, you're probably going to want to do anyway. That way you can take your GPM readings. So that's how I kind of delve away from that. O-rings, I did touch on, right? Okay.
The next question, which you just said about back flushing, is how do you purge out unit after using it, or do you need to rinse it out also, especially if unit will be down for 1 to 2 weeks?
Yeah, so going along with that same answer as the last question, if you've got some old molds that just have the straight through and it's, P20, H13, I get guys that just leave a little bit in there. But again, you want to recapture and reuse it. So if you're leaving all the chemical behind, you're not gaining it all back to continue PMing other tools, but it is good practice to get into flushing. Again, going back to those non-ferrous alloys, but I've got other guys that they'll flush, and if that tool is hot and has a machine ready to go, they don't even back flush. It just goes into production. The facility water dilutes it. So yeah.
We did get another question. Can I run this through my manifolds?
Yes, I actually did touch on that question earlier. You can run it through your manifolds. Just be sure to inspect your manifolds prior to doing so. Also, I mentioned it's safe to walk away from your unit while it's running. The 2 things that you want to do are visually inspect that it stays this translucent green. We talked about discoloration with glycol. And 2, listen so you can hear that cavitation of the pump. If you started it and you've got, good solid cavitation, and you come by a little bit later and you notice that it's slowed down, odds are it's your filter. Another thing I wanted to mention while I'm thinking of it, I mentioned this pump is designed to last 3 million strokes. Now that we have users that have been using this for 3.5 years now, I wouldn't say it's terribly common, but it's starting to come up, are maintenance on the machine itself. So I got a pump, it's an air diaphragm pump on the backside right here. To access the back panel of the cart, pop these 4 bolts, your air fitting, you have all the meat and potatoes behind it. What can happen, and that gentleman said, especially if the unit will be down for 1 to 2 weeks, if you leave it set for 6 months and you didn't backflush with water, what can happen is some of this chalk white, which I don't know if you can see it on this cart from there or not. Here's a good example. This is an example of chemical left on and not dried. It turns this like chalk white coloration. That same chalkiness can build up in the balls of these manifolds, and it'll just cause them to stick. They're PTFE balls. So if you're, again, not running water and the unit sits for 6 months or so, you may need to run, I usually say hot water. Water breaks it down, heat speeds up the reaction. You can run a little bit of water through the unit and it'll kick right back on. That's probably, now from some of our older units that are now approaching 3.5, 4 years old, and guys just kind of let it sit in the corner. I'm getting more of that. So was there a question about safetiness and exposure? I feel like that I glossed over that.
Oh, yes, there was, yeah, pH and or safety of exposure to the liquid.
Yeah, you should always wear full PPE. I work with it in my bare hands. I understand everybody has different chemical sensitivities, gloves, eyes. If you were to get in an open wound, it's similar to like that tingling sensation that mineral spirits gives you. It's in the same classification. A great analogy that I like to use is bleach. You know, so understand the scenario that you're using it in. Obviously, this is 85% diluted. It's not full concentrated, but if I'm working with 100% bleach scrubbing my toilets, which that will never happen, my wife would kill me if it got to that point. But if I'm in that scenario, I'm putting on gloves, I'm putting on ventilation, I'm putting on eye glass because I don't want the fumes to get to me. If I've got bleach at a 1 to 20 in a spray bottle and I'm just spot cleaning things, you know, I'm not putting on all the necessary things that I would if I was at 100% in an enclosed area. So that's a great question. So was there another one? I think I got that one.
No other questions as of right now. So if you all would like to send in anything in the chat, I do want to just show really quick our YouTube page, that we are trying to get to 1,000 subscribers. So if you could hit that subscribe button, we'd really appreciate it. But we do have our playlists here, and we have our preventative maintenance cleaning system, which this playlist has some amazing videos we've made on the EcoPro, on your you know, your PM programs and all that. So just wanted to point that out. But I do think we did just get another question. Okay. The question is, can you use on heat exchangers and feed zone block that also runs water? I've seen blockage before.
Yeah, absolutely. I clean out plate style, tube style. Again, getting back to oil and water not mixing. If you're running oil on your shell side and water on your tube side, obviously don't clean out, you know, the shell side with water or with that has oil in it. Plate styles, basically anything that's running water that experiences scale and contamination that you can connect to and get out, you know, 98% of the water, 90% of the water. That way you're not diluting the chemical. As long as you can hook up to it, you can flush it. I wish I would have posted a photo. I recently did, they were an extrusion manufacturer and they had a sidecar with 5 heat exchangers, 4 for the rolls and 1 as a backup. And we plumbed in quick fittings. So even though heat exchangers don't block up and go down that often, again, depending upon the area and your water quality, let's say your heat exchanger blocks up every 14 months. Well, you throw on these quick connects similar to what I did here. And then every, I don't know, 10 months, hook up and flush for an hour. That way that heat exchanger doesn't crash on you. And then, you know, they're expensive and they're on back order right now, like most things are. So if you can do anything to prevent that, then all the power to it. If you want to look for questions, I'm going to dump this chemical out.
We do have a few more minutes here if anyone else has any questions.
Show that new cart too.
Also, if anyone's feeling brave to unmute their microphone, Brian we have a TV set up and he can hear. So if anyone is interested in unmuting and asking a question, that is more than welcome, or you can just send it in the chat.
And that's also a good segue into, and I'll show you guys these new carts. I know we're running out of time. You know, we do on-site demonstrations and demos and training. So if you wanted to see that up, we offer a lunch and learn, which that program can be found at idadditives.com. I lost my train of thought. But I want to show you the new cart.
We did get a question in, wondering about portable chillers. Is that something that we can flush?
Portable chillers, TCUs, thermalators, water jackets on extrusion line. Odds are we flushed it successfully. I don't know how to park this thing, but this is the new cart. I mentioned some of the changes. I guess you can't really see it from there. I'll maneuver it here in a second. This is how you can expect your cart to come. It'd be shrink wrapped. You can see the new laser engraved plaques on the side, the gloss black. Nobody's ever asked me to do a show model like this before, so this is new. A little walk around. But again, just purely cosmetic. So that's the new cart. Oh, that's what I said. I lost my train of thought earlier. If you wanted to do a one-on-one video demonstration and have your team in the room, maybe you don't want to ask questions in front of everybody, which I totally get. We're welcome to do, or you're welcome to ask me to do this same setup. I can move around the cart. I can move the camera, show you how things operate. But there are two really good videos on YouTube. One is a short intro, and it's got the steps that walk through it. There's another one that's maybe 11 minutes long. It goes a little bit more in depth, and that's more of a training video that you can showcase to your guys as well. But I'm always happy to set up a Teams, whether it's here at my desk, in person. Please do reach out. So I think with that, I'm going to save you guys a little bit of time. Again, I really appreciate your time here with me. If I can be a resource, whether you have questions about your Reynolds number or doing some calculations based on your processing temps, please do consider me a resource. I've been in countless shops now. So I've seen a lot of things go wrong, and I've seen a lot of things done very well. And if I can be a resource and help steer you in the right direction, even if it's not purchasing one of my units, if you say, hey, this is what we're doing, what do you think? I'm more than happy to be a resource. So that's why our tagline is unmatched technical support for innovative products. We want to help.